to go ahead and get started. We're very pleased today to have Nyla Beth Gawel from Booz Allen, one of our sponsors. If you haven't had a chance, please be sure to check out their table and some of the great data science resources they have. Nyla Beth is a program manager with more than 15 years of experience, and she's also leading Booz Allen's strategy on Internet of Things. She's going to be talking about generating value from data in the connected world. Please welcome Nyla Beth.
Thank you. Thank you all so much for being here on a Sunday afternoon when the weather is that beautiful with that view, and while, as I last checked, the Patriots are still up over the Bills. As mentioned, my background is in Internet of Things, and I'm not a data scientist. I'm actually more from the technology side, focusing right now on how the various plurality of devices can actually be used to create new solutions. But how many people here have heard already about all the large predictions of just the power of IoT and what it can bring? Usually it has terms like billions, trillions, and even bigger numbers in it. Anybody hear some of these yet today? There's a lot. I'm not here to talk about actually what all of those predictions may be, but much like the session that was in here immediately before, which talks so much about solving real challenges in life, such as autism, through the incorporation of technology and data. How can we use that power to create new, unique ways to actually address the power of what IoT can bring? So I don't want to talk about solutions, because the challenge I think that happens in talking about that is that you forget that a solution is an answer to a problem. So the bigger question here is, what are the various problems or real-life situations that IoT can be a way in which us as innovators, as data scientists, and as business professionals actually can make an impact? Problems exist all around us, ranging from health and wellness to even the chaos of Boston traffic. As a resident in Washington, D.C., very empathetic to that situation, especially as we prepare for a Pope's visit that's shutting down our city this week. But in these problems, it's how we can step in, diagnose the issues through the principles of data science, and then define the solutions using skills and resources that the data science and analytics field have today, not those that we need to worry about planning for over the next 20 years. So I want to start by describing what I think is the difference between enterprise and consumer IoT, and then talk about the opportunities that IoT will bring for data scientists across very specific industries. And then look at everything from a framework we call the Data Prism, a way in which to apply data from a design, edge analytics, and big data analytics viewpoint as a continuous feedback loop across industry to actually enable a value and an operational decision ability for many companies. Finally, I want to talk about making IoT real, how we can use this Data Prism framework to address real-world issues. I mentioned traffic. That's a hint that one of the use cases we'll talk about is very related to transportation. So consumer IoT is something that we all hear a lot about, and probably many of us already embed and use in our existing lives. It's about making our lives comfortable, easier, more accessible, and even healthier. Consumer IoT is what allows me, for example, to automatically start my car, have my coffee maker, already brew the coffee to my designed likings, and even adjust the thermostat in my house so that on a cold winter day, before I even wake up, or even from the comfort of my own bed and an app, I have a level or modicum of comfort. In the health or fitness area, it's the way in which we track our steps. It's the way in which we think about how we're meeting fitness goals. So in so many ways, IoT is just completely already around us as consumers. It comes down to the concept of giving us individual intelligence. An intelligence that in many cases we didn't even ask for. We didn't know sometimes the questions we had to ask. But because of technology underpinning and the underpinning of data, we're already enabled a new view of expectations in our lifestyle. Enterprise IoT, though, is rooted in many of these same concepts, but is much grander on scale. My coffee, my temperature, those are nice to have. If my job were to be the CEO of an energy or oil refinery plant, Those nice-to-haves are way lower on a priority list than the safety of the workers and staff that I would employ, the knowledge that a pipeline is working effectively and not leaking, and the understanding of the building operations, the safety, security for everything that is included in my enterprise or my infrastructure. And that is what makes enterprise IoT mission critical. The understanding of how these complex networks actually engage amongst themselves. So enterprise IoT is a scenario in which the physical objects and people within and across an entire organization, a business, or a company, or even the entirety of an industry are given unique identifiers that allow them to transfer the data over a network without needing person-to-person or even person-to-machine interaction. A recent example with Cisco, as a matter of fact, was able to show the value that this can bring for a company. Cisco found that offices and cubicles in one of their larger facilities were vacant 65% of the time. After performing analytics on that data, interviewing some of their employees, they realized the majority of the workforce had unique working hours. Maybe it was 6 a.m. to 3 p.m., or it was coming in later and staying later. The ability to look at that data, analyze it, and create actually a whole new workplace policy that they considered a connected workplace enabled them to redesign the concepts of their own layout, of their own workforce and staff expectations, and in result save a significant amount of money. For example, they were allowed to use their RFID-enabled badges to check in and out of rooms, and when those rooms were not in use, all of the technology, the lighting, etc. was disabled. They further found that most of their staff were busy collaborating and moving during the day, room to room, and using meeting rooms more than they were ever using cubicles. So they actually had the opportunity to redesign the framework of their space. In so doing, they dropped the number of wall jacks and of other AV components from 6 to 2, since they were not in use, saving at least $800 per employee. When you think about that on the scale of any company, especially the large companies or enterprises, you're looking at mass savings. That's just one example that gets at the business optimization or efficiency. There's many more we're going to talk about today. But as we think about this and we look at how the price of sensors, the price of technology has gone down so significantly because of mobile phone technology and the explosion that is all around us, it makes IoT not just affordable for an enterprise, but pretty much table stakes for how they can continue to provide their business and mission critical value to not only their workforce, but their consumers as well. So some of the industries where we're seeing a high prevalence of early adoption of this integration of IoT with an underpinning and reliance on data science are listed here, ranging from health, energy, transportation, facilities, manufacturing, and even in our defense and intelligence areas within the government. In these areas, enterprise IoT is looking at the safety and security of operations, and as I mentioned, the business value. Here, it's more than an ambiguous monetization or prediction. It's actually looking at very specific ways that these industries are using their existing infrastructure, applying new views of analytics and data science, and coming up with an increased value for their organization. In transportation, for example, you're seeing this already with optimizations of speed control. The way in which, for example, maybe a subway system or a train actually have governors that disable them from going above certain speed and provide new alerts and warnings both to command and control centers and to the drivers. Additionally, we've got improved vehicle design that is informing new traffic policies across how any type of vehicle, whether you be talking about a car, the train, or others, actually function. In the manufacturing industry, we're seeing a huge explosion right now in factories and other forms of the industry is looking at predictive maintenance, how to address equipment challenges before they actually break or fail, how to remove the workforce from having to go do routine checks on equipment that may often not even be needed. It's creating safety and security for their workforce, and it's actually improving their efficiency overall. And in energy, I mentioned the example about saving costs on energy in a building, but it goes all the way through demand-based energy management. Everything from smart meters to what we're seeing even in how we measure the variability of what is right now our oil reserves. And I talked a little bit about health. I did so in the standpoint of wellness. But if we think about health as an enterprise, this is where you can begin to look at how hospitals are actually enabled to track the patients through new monitoring, track actually potential hospital-acquired infections, and look at the data of where various assets, not just the people, but all of the tools in a hospital have been, and correlate ways to actually decrease potential for future infections within those who enter any hospital or safety setting. But the question is, how do we realize these values? These are all great case studies, and I think many of us could say that the technology is already there to do a lot of this. And even I think data science is already there to say once you get the data, a lot can be done with it. But the question is therefore not how do we access the data, but what more can we do with what is really going to be a huge boom in IoT data. It's a huge boom in the data that will be created through these connected devices. At our company, we have more than 500 data scientists, and they use analytics in many of the engagements with clients to figure out solutions to problems. It's through this concept, though, we're going to talk about of a data prism that we look at how can you not only look at a framework for applying design, edge, and stream, and even big data analytics against a problem, but how can you use all of that information as a feedback loop to redesign the infrastructures, the technologies, and re-inform the breadth of what that enterprise IoT system may need to entail. I'm going to walk through the Data Prism platform and then talk about some specific use cases where we've seen it applied. So as I mentioned, it's an analytics framework for thinking about data ingestion, analytics platforms, and note I say that plural, and then the automation and visualization of analytics to address very specific business and operational needs. Much like the interconnectedness of IoT, what we're seeing here is an interconnectedness and correlation of not just the data and the technology, but therefore for an enterprise, for a company, of the entire ecosystem it needs to think through across its providers, vendors, service providers, vendors, and manufacturers to enable this. So we start with data ingestion. In an IoT landscape, we think about that as a sensor. Sensors are everywhere. I mentioned before the cost is only declining, further enabling the ability to put sensors in many new and unique places, let's say, depending on the industry. So having sensors could mean having what we would consider legacy or dumb sensors. These are sensors that maybe have been out in a company for years, maybe even decades in some companies who have been using them for a long time. Sensors that collect any and all data that is against which they're assigned. It could be, though, smart sensors, those that right now are programmed to actually already sort through the data that's coming in to look for very specific pieces of data and only be able to pull and ingest those. And then we've got human sensors. So much of the talk of IoT is all about the technology, but if you think about it from an enterprise, people collect data. Maybe it's a field worker who is sent out to check on the status of a various pipeline. They may be collecting that data into some type of automated case management form. In and of itself, that becomes a form of a sensor. So how all of these get ingested is really important to understand from an enterprise perspective, because it changes an understanding, therefore, of what are those analytics platforms that are most relevant to be able to correlate and understand the data. We're talking here about a high degree of variability in data. Some already selected because the problem was known, the question was asked, and it's been defined. Some because they're a legacy and getting everything, and some because at this point, an industry has maybe hypotheses of what it may need to collect in the future. So once all that data is ingested, you then get to the analytics platforms, and as I mentioned, plural. It could be anything from Splunk, Hadoop, Cloudera, and many, many other examples. But the point here is that when you're thinking about it from an enterprise perspective, you might be looking at what is the platform that your financial department uses? What is the platform that one of your operational units use? They could be very different platforms based on the nature of the data and the nature of what needs to be done with that data. The question then becomes, how do you correlate those platforms? So what is the way in which you can make sure you're using the appropriate platform for the data and the analytics you need to ingest and work with, but that it in and of itself can be used across the entirety of whatever a company or organization may need to do. So then the third step in thinking about this is then looking at what are the different types of the analytics that need to be performed. Edge, stream, and even deep analytics that can be fed back into the system and the mission operations in a continuous feedback loop so that the technology deployed also can improve over time. It's through this process that you actually begin to think about something that is more in what industry would consider an end-to-end solution against a known set of problems. So starting at the edge, IoT analytics really does start right there at the edge. Any successful IoT implementation needs to have certain components and capabilities that meet specific demands. So I mentioned sensors and the variability of sensors and how you get that information. Understanding that breadth and realm actually may help you think through what is the right type of sensor to be deployed. Do you need all the data? I think most data scientists say too much data is not normally the problem. You would rather have more than less. But in some cases, and enterprises already said, I know what I need to know and I know what data would answer those questions. So you already have that kind of self-selection process. You then have standards, the rules and the protocols that must be followed in the system in order for it to function correctly. And here I mean two different types of standards. I mean your technical standards that make sure however you think about deploying sensors actually relate to the rest of your technology. But I really mean also the data-related standards, different data models and architectures and how that can be developed in coordination and collaboration with your understanding of the different types of technology that you have access to. Then there's the connectivity between all of those devices. So often, I think we don't think about connectivity. We take it for granted. Probably everybody in this room has at least one device connected to either the Wi-Fi here, maybe also connected to your cellular signal provider. There's frustration when you can't get the broadband speed that you want. But now what do you do if you're in charge of an organization that has an oil pipeline that goes, let's say, maybe to Antarctica? Or what do you do if you're the owner of a large-scale farm and you're trying to check your soil temperatures and your water flows in areas where cellular coverage isn't provided? What do you do then? Connectivity is an important part, therefore, in understanding what type of data analytics you can do and where you can do the analytics. If the cloud isn't accessible, for example, how else are you going to get the information? So it becomes a really, really pivotal way of understanding what's feasible at the edge. And then you have intelligent gateways. These are the components of IoT that help make sure that the information is coming in and going to the right users of it, whether it be up to the cloud in many cases, or even in some cases to actually a data center. In all of this, you have to think about the ability to operate autonomously. So as I mentioned, connectivity is really important. And so what do you do when you don't have it? How can you make sure that the gateways or the sensors can actually continue to operate? And this is where this concept of a feedback loop is important. It's using technology that has learned, based on the algorithms and the decisions and the analytics you need to know, what decisions it can make on its own. And this then enables it to have the ability to respond to data-driven commands, so that as a sensor detects information, that information can be processed, analyzed, sent where it needs to be, but also can create a command or a direction to some other part of the network. An example of this type of data-driven command is, for example, in a nuclear power plant. It's in an area where there is already a vast adoption of IoT, because there's already a significant amount of sensors and analytics that can actually detect and correlate different types of information. So you know, for example, temperatures on the rise, actually the decisions could occur such that the cloud or a sensor or a gateway could actually already know that the temperature is on the rise, therefore the increase of water flow needs to occur to make it actually the reactor cool enough. At a certain point, that same component of the network can actually send a command to say the temperature is okay, stop the induction of water, and all can continue. So edge analytics is where we start seeing this ability to then look at this little autonomous way in which the technology and the data start living together. And it's the point at which you can start seeing the commands be generated to actually then affect stream analytics and the deeper, larger, big data type of analytics as well. So of course, that leads me to stream analytics. So what's different between the edge analytics and the stream analytics here? Stream analytics, in our view, is what we start seeing to improve tactical decision-making in your operational processes. So an example I just used of the coolant in the reactor, that's great for one. But what if you're managing multiple reactors? Or what if you're in charge of multiple plants? This is, when you think again about an enterprise or a corporate instantiation of IoT, this is where stream analytics comes to play. And in order to have stream analytics, you have to begin with having some defined outputs. Once you have the data in that analytics platform or platforms, what is it that you really want to get out of it? Is it a decision? Is it awareness? Decision means you need to build in some type of commands. Awareness, while still maybe needing commands, but it could mean it manifests in alerts. So within that, you have to establish the kinds of rules that you're going to put around the data. For example, maybe it's something as simple as if more than 10 data samples come up with a very specific outcome, then a threshold is achieved, an alert is sent. But even then, what's that work stream? How do you define the appropriate work stream to know how you are collecting it, how you are going to store that information, how are you going to transform it into that decision, and then how are you from there going to visualize that? And I think visualization actually is a challenging term to use there, because I think visualization is more than just what you can display, although there's various ways to display the results of all of this. But it could be an audio alert. It could be a vibration. It's the way in which the compilation of all of these analytics has to now make an enterprise accountable to some type of decision. And successful enterprise IoT, it's going to require then this communication between the edge, the stream, and then of course, the deeper analytics. Deep analytics is where we start getting, frankly, creative. It's where we get much more forward-looking. It's enabling a much more strategic view than just either the edge or the streaming analytics can provide over often a much longer period of time across different trends, different patterns, and correlating different ways to think about actionable insights. So to be successful in deep analytics, you need to be thinking about now the right infrastructure for IoT. And IoT infrastructure is a little bit more unique here because the data is growing exponentially faster than most data sets that data science are currently working with. So gathering it, storing, and manipulating the data becomes exponentially more challenging. And I think when you think the term IoT, so I mentioned before, you hear all about the billions, the trillions, and all of these projections. I think the key to take away is that the word exponential comes into play in all of these cases. So we have to think about things, for example, like accumulation. You need a fast, streamlined process to collect the vast amounts of data. We'll get into some other statistics in the use case, but data can be collected multiple times per second. Maybe it's multiple times per year. In some industries, they collect data once a year. And so you have a much more longitudinal need for it. But across all of this, accumulation is a really important way in which you then impact your storage. The ability to store as much data for as long a period of time as possible is absolutely critical, which means storage has to be robust, it has to be scalable, secure, and for anybody who sat in Deborah Hurley's presentation earlier, it has to be compliant. So many industries are regulated very strictly with what can be collected and once collected, what they can do with it. So the understanding to know that what's collected today, there might be new laws in the future on how that can be used. So we have a compliancy angle there as well. And then you have the retrieval. Who can actually access that data for what purposes? Compliance again comes in there and the ramifications on that. And then finally, it's the redundancy. How can each user that's authorized have the right access and controls, but know that the data is always going to be there? So making sure across the accumulation, storage, retrieval, and then also having the right infrastructural redundancy, that it's all enabled. And this is where the fun, I think, comes to play for data scientists. It's where you can involve the creativity in the forward-looking way. I think we all know data science means more than just having a software background to be able to ask the right questions and perform the right queries. I'd say here, more importantly than ever, it's about having the intrinsic skills that data scientists have to be able to look for massive trends, to be able to look and project what questions could be asked based on data sets. And I think more and more, knowing those types of patterns and trends to potentially look for is what actually creates then the business value. And to ensure that there's that business value and there's that operational success. This is where data scientists have a unique role in enterprises to partner with industry experts or people maybe who understand the ins and outs of those businesses to drive the insights into action. For example, in manufacturing, you could have a lot of data scientists who could come up with an optimal time to work through, for example, an assembly line and find new ways to improve that, even new ways to tell the technology to go faster or better. But understanding the value of that is going to come into knowing what the testing timelines and protocols are for the products that come off that assembly line to make sure that the business actually can realize a much longer term value on that investment as well. So implicit in a lot of what I'm saying is that the data actually in an IoT arena actually enables different design considerations. So for example, thinking about this complexity of the data that you're talking about in any company or in any industry, it's going to be massive at high volume, high velocity, and with a high degree of variability or variety. And to determine, therefore, the right design that you would need of your IoT infrastructure, you need to think about the right type of sensor, understand those data inputs, the required outputs, operational constraints to deployment, and again, these 3 V's. Velocity. We talked about the speed earlier of the data. How fast is it going to be coming in? How slow is it going to be coming in? And what is going to be the pace at which decisions have to be made on that data? Volume. This isn't just meaning the full volume of all the data, but specifically each element of the data. Is it in small packet form? Are you looking at massive video files that are coming in constantly? So volume has in and of itself different characteristics. And then variety. Structured data, you're getting spreadsheets from a workforce all submitting information. Or is it unstructured? You're talking about Twitter feeds, trying to figure out your corporate brand and how that's being understood and how that is being correlated back to your bottom line and to the efficiency of your product line. All of these and many more are also considerations when you think about the infrastructure of IoT. Things like mobility. Does the design of the IoT need to be mobile? Do sensors need to be able to be replaced to move? What about the form factors? There are weight and size issues. We mentioned before connectivity, so communications. How are you building that into the information to make sure you access and get the right data? And finally, your environment. Are you looking at deploying things that need to be, back in the example I mentioned, literally in Antarctica? Or are you in temperate climates? Are you in intrinsically safe places? For anybody who's ever been in a chemical refinery, there's a lot of reactions that happen. So the way in which you think about the technology and the data you need could actually collide, literally collide, because if it's not intrinsically safe to certain standards for that industry, it's hard to deploy. And this is where data analytics in IoT has, as I mentioned before, the term the feedback loop. And thinking and understanding the concept of a functional architecture, that's definitely a technology term in many ways because you're informing the technology. But you're not just starting left to right and talking about, for example, how the sensors led all the way to some type of value for an organization, but you're now turning around and going right to left and thinking about how that value actually can change what it is that the infrastructure is, needs to be, or can be. And even to some case, I'd say, changes what the manufacturing or the industry that creates all of those devices or services can provide. So, for example, we know that if you set an oxygen level at 90%, let's say in a given environment, maybe it's in an office building or in a factory, you can have sensors and alerts that trigger and tell you when something ever goes below. That could let your workers know that they need to exit the building. It could let them know it's a compromised environment. But how can you get that information back actually into the products and the environment that caused it to go low in the first place and actually create a full cycle by which IoT is not only giving you your value, but it's changing what it is that your infrastructure had to begin with. And it's through this lens that data analytics and the technology of IoT don't just provide an end-all value for companies and for individuals, but back into the industries that are their underpinning or the technology infrastructure they're in. So I mentioned, return to my favorite topic these days, which is traffic and avoiding it. And this is actually a use case where we've seen this Data Prism really come to bear. So traffic congestion in the US, and a few statistics I thought were really interesting. It costs us as taxpayers and through the US $87.2 billion per year, 4.2 billion hours of labor, and 2.8 billion gallons of fuel just spent sitting in traffic. The connected vehicle technology research has been going on for 10 to 15 years. If you've ever seen a Tesla advertisement or even on commercials for cars that will remotely tell you if someone's standing behind you and even initiate the brakes for you, you know that there is a reality there that cars can communicate with each other and intrinsically within themselves. A lot of this through dedicated short-range communications is already doable. The research has been done. But now how do you expand this into the environment in which cars exist? The roads, the people around them, the drivers, other cars. This is where the connected vehicle is going, and it's actually at the stage right now of demonstration. I think innovators and technologists can understand that we can't rely on current data to figure out where the future of the automobile industry needs to be. We need to figure out what is the type of data that would be needed that can help feed back into the way in which these products are manufactured. Earlier this week, the White House announced a new Smart Cities initiative to infuse more than $160 million into federal research and development to do a series of things through 25 technology collaboration sites. They're looking at everything from fighting crime to improving citizen services to improving traffic management. And as part of the Smart Cities initiative, the Department of Transportation actually has $42 million in new funding to do 3 unique pilots where they're going to actually take the real-world availability of technology, the known needs of data, the existing data sets, and actually go apply them on specific roads. We're excited to be involved in standing up what they're going to be doing in one of these pilot sites in Tampa, Florida. And this is where some of the autonomous information that the vehicles collect, along with the infrastructure around them, will actually be get to seeing how it can work and infuse a new way of working together. As part of the Connected Vehicles Pilot Deployment Program, you're actually looking at the ability to look at the streaming, real-time data analytics platforms, and the visualization tools. So again, those 3 components to see about how instrumentation on the roadway can actually be included with connected vehicles to ensure that the roads and the cars are now talking to each other. When we think about connected transport and vehicles, we're looking at a very complex set of industries, all of which are engaged in this. You're looking at municipal, state, federal data sets, the automobile industry. You're looking at traffic management systems, often privatized to other players, weather, and other influencing factors here. So it goes back to basically showing data is going to be massive. The need to look at this and design the entirety of the system has to address, therefore, then also the volume, velocity, and again, that variety of the data. So what we're doing in this project is we're using that Prism model. We're first starting with a data ingestion engine, leveraging a suite of existing data as well as existing technologies to actually take the vehicle data in real time and actually look at it across a series of different platforms. Then within those vehicle analytics platforms, we're actually looking at different ways using our data scientists, creating different new and unique algorithms to look at historical, real-time, and predictive analytics to actually show some new insights and lessons learned regarding the transportation system managers' abilities to make decisions on the road for safety, mobility, and also for environmental benefits. And then we're creating the visualization interface, be able to look at the contextual, static, and animated graphics and how they communicate this insight. So this pilot is just, as I mentioned, one of 3, and is really only the beginning of taking known concepts in technology and data and making them real, instantiating them in the field in a way that we can actually start seeing not only benefits, but taking that information and putting it back into a series of enterprises, the automotive enterprise, traffic and local government enterprises, as well as all the component manufacturers and service providers therein. And it's that ability to look at how to address real-world problems and think about where data analytics and where data science can go vis-a-vis IoT that actually becomes the way in which we think about not just creating IoT solutions, but by which we all need to be able to think about what are the right problems to be solving and what is the two-way exchange of information to to see data actually from a source to a user, and also feeding back from the user to create new sources, new technology, and new infrastructures. And it's from that lens that I think the concept of making IoT real and leaning forward with the data science and the analytics to do so is really the exciting part for enterprise IoT moving forward. So with that, ask for any questions or discussion points.